Today's class will see about different types of wave propagation, that is to communicate signals from one point to another point. We have these different modes of wave propagation. So we have basically three types of wave propagations. One we have is ground wave propagation, where the frequency for which this mode of propagation can be used is less than 2 megahertz frequency. The second one we can have is sky wave propagation. The frequency here which we can use is about 3 to 30 megahertz or up to 40 megahertz we can have. In case of sky wave propagation, we can use the frequencies or applications up to the frequencies 40 megahertz. And third one we have tropospheric wave propagation, tropospheric or space wave propagation we can have. Space wave propagation or tropospheric wave propagation, space wave propagation. So these are the three types of wave propagation which we have. Based on the different frequencies, we use these different wave propagations. So we'll see the diagram for this three types we have. In case of ground wave propagation, the frequency for which it is used is 2 megahertz, up to 2 megahertz. Sky wave propagation we can have up to 3 to 30 megahertz, or sometimes it is up to 40 megahertz. Sky wave propagation is also called as ionospheric wave propagation. Ionospheric wave propagation because ionosphere is used for this sky wave propagation. That is, the signals which are transmitted from the transmitter station are reflected and refracted by the ionosphere, and they will receive at the receiver station. Sky wave propagation. So that's why it is also called as ionospheric wave propagation. So here we have, first we'll see about ground wave propagation, little detail. Ground wave propagation, and in this we have why this is called as ground wave. The ground waves are propagated near to the earth's surface. Ground waves are the waves which are propagated near the earth's surface. That's why these waves are called as ground waves. So ground waves are nothing but which propagate near to the earth's surface. So when the transmitting and receiving antennas are close to each other, that is to the earth's surface also, and the distance which this mode of wave propagation covers is less compared to our sky wave and space wave propagation. Less distance which it covers from transmitter to receiver antenna, and the antennas are also close to the earth's surface. And further, these ground waves are divided into two parts. Ground waves, two different we can have. One is space waves, another is surface waves we can have. Space waves and surface waves, these are the two types in the sense, after reflecting, if it is receiving to the receiver antenna, then it is called as surface or ground reflected waves. If the signal is directly coming from the antenna, suppose we have this antenna, this is transmitter antenna, and we have the receiver antenna on the earth surface. One signal, it is going to come directly from the transmitter antenna to the receiver antenna. This is called as space waves or direct waves. The signal comes directly to the receiver antenna, and some waves, when they are transmitted, they come and reflected from the earth's surface and they reach to the receiver antenna. This is the earth's surface, so they reflect from the earth's surface, then they reach to the receiver antenna. So this type are called as ground reflected waves or surface waves. The waves which propagate to the receiver antenna through the reflections from the earth's surface are called as ground reflected waves or surface waves. So when they receive, the surface wave is guided by the surface of the earth, and that will receive to the receiver antenna. And here this ground wave based wave propagation, it is used for broadband. The band of frequency for which it can be used is large, but it is low frequency in the sense this can be used only up to 2 megahertz frequency only it can be used. Above 2 megahertz frequency if you use, losses will be more. Below 2 megahertz frequency only it is used, because as the frequency is low, the wavelength is going to be longer wavelength, and that will be along the surface of the earth that will travel, and losses will be less for frequencies less than 2 megahertz. So we can use this ground mode of propagation, that is ground wave mode of propagation, for frequencies less than 2 megahertz only. And we'll see now a diagram which gives all the three modes of propagation. This diagram you have to draw in the exam. This is the earth surface, we have earth curvature, we have taken earth surface. Now we have the transmitter antenna here, and we have the receiver antenna some near distance to the, that is, this is transmitter, this is the earth surface, we can have transmitter, and this is received antenna, this transmitter antenna, and this is receiver antenna. So near, so then this type of wave propagation is ground wave propagation. In this ground waves we have two types, already we have discussed. One comes directly to the receiver antenna, one comes from reflection of the earth surface. So this is for ground wave propagation, and this is used for line of sight communication, LOS. That is, for example, if you have aeroplane is flying above the earth surface, so line of sight communication it is used. You can send the signals to the aeroplane, and from there you can get the signals. That is with respect to ground wave propagation. Now we can have another mode of propagation, that is space wave, and that is tropospheric wave propagation and sky wave propagation. That is we'll see here. So these diagrams, these are, and the curves are nothing but antennas. And first we'll say about sky wave propagation, which uses ionosphere for the communication purpose, So we have the ionospheric layer above the earth's surface around, some books gives 80 kilometers, some books gives 90 kilometers, up to 450 kilometers above the earth's surface. You're going to have the ionosphere. Different layers will be there, C, D, E, F1, like different ionospheric layers will be there. We'll see in detail when we see the separately skywave propagation in other video lectures. Now this is ionosphere, we have ionosphere, INOSPERE, ionosphere, this is, which is from the earth surface, it is about 90 kilometers above the earth surface starts. Some books give 60 kilometers, some books gives 80 kilometers above the earth surface to around 450 kilometers above the earth surface. This is going to be ionosphere, it is called ionosphere, SPHERE. So the signals which are transmitted from this transmitting antenna, they are returned back to the receiver antenna by reflecting and refracted by the ionosphere. So this is nothing but for skywave propagation. This is with respect to skywave propagation, which uses ionospheric layer. And right, sky waves here we call the waves reaching the receiving antenna as a result of scattering and reflection by the ionization layer. They scatter and reflected by the ionosphere layer and they receive to the receiver antenna, that is called as sky waves. I'll write the definition of sky wave after explaining this. Another one we have space wave, which is, if you have a satellite here, we have a satellite, suppose this is a satellite, the signal is transmitted and received by the satellite, and that is again retransmit to the receiver antenna. So this is transmitter and this is receiver antenna. So this type of communication which uses, this is space wave propagation. Space wave propagation it is. Okay, the distance covered by the skywave propagation is very long. It covers thousands of kilometers. It will cover thousands of kilometers. It covers. This is space wave and skywave. These are the three modes of wave propagation which we can have. Now we'll see about skywave propagation little in detail. What is a sky wave here is the wave reaching the receiving antenna as a result of scattering and reflections by the ionization layer are called as sky waves. So we have sky wave propagation. This is the second one. Sky wave propagation we have. Sky wave propagation. In this, sky wave is nothing but I have told, and this uses, I'll just write what is sky wave. Sky wave, the waves reaching the receiving antenna as a result of scattering and reflection by ionization layer. Scattering and reflecting by ionization layer. So this is about sky wave, and it utilizes ionosphere, that is above the earth surface, 90, 80 kilometers, 60 kilometers above the earth surface ionosphere starts. So that's why this type of wave propagation is also called as ionospheric wave propagation. Ionospheric wave propagation. Right. Next one, third one we'll see, that is tropospheric wave propagation, also called as space wave propagation. This tropospheric wave propagation utilizes the troposphere above the earth's surface, which is present at a height of 15 kilometers from the earth's surface. We have 15 kilometers. So third one we have is, third mode of wave propagation we have is tropospheric wave propagation, or another name we can, it is given as space wave propagation, because this mode of wave propagation utilizes the troposphere, which is present above the earth's surface around 15 kilometers from above the earth's surface. You're going to have the troposphere starts, and the waves which are reflected are scattered in the troposphere before reaching to the receiving antenna are called as tropospheric waves. Tropospheric waves they are called. Okay, you can write the same as we have written for ionospheric waves. For tropospheric waves also you can write, that is the waves which are reflected are scattered, reflected are scattered in the troposphere, which is above that surface, and they are going to reach to the receiver antenna. These are called as tropospheric waves, and this mode of wave propagation is called as space wave propagation and tropospheric mode of wave propagation. So alternative, we can have this three types of wave propagation. In detail we'll see in another video lecture. Thank you. Please subscribe the channel.